glad to be here. Thank you for inviting me. I love to be over in Barcelona. So even if some of you don't speak English very well, there's lots of pictures in my presentation, and I'm just glad of the opportunity to come here and see your beautiful city. So SBS, we do a lot of work with FME. We work very closely with Conterra. We're support partners to them. We don't do a lot of work here directly on FME implementations, but we provide tools that are used for implementation. So basically, I'm here to talk about some examples of the things that we're doing in America with some of our utility network customers. So basically talking about some of the things that we do, specifically this thing called Delta Sync, which is a synchronization architecture that we use to bring data between small world primarily and the utility network in a two-way replication scenario. But it can be used in other systems as well. And then there's other integration requirements that I kind of talk about as well. This is an overview of the whole architecture. Really of interest, we have a small world plugin that SBS write and maintain, and then we also have an ArcPro plugin, which is for the utility network, which is really capable of doing a lot of powerful things with the utility network data. When we put them all together with some supporting transformers that I'll talk about at a very high level, and some workspaces, we can basically take data from small world, synchronize it to the UN, and then take it back again, doing incremental change detection on both sides and bringing those changes over, and then FME is doing the transformation process. The plugin, the utility network plugin, has lots and lots of capabilities. So I mean, I've written down here there are two plugins that FME themselves produce, or SAFE rather produce, for ArcGIS, but they're not really geared towards the utility network. They're more just pure ArcGIS. So where our plugin goes a little bit more is that it's physically working with the utility network plugin extension rather than if it's loaded up, it can do things like go into the network connectivity, go into the associations, look at the extended rules, tables, attributions and stuff like that. And it basically gives you access to all that more detailed information. So it uses the ArcGIS REST services directly. It's not using the C# interfaces. The writer capabilities supports incremental updates, writing of associations, the reader capabilities. You can either read all the data, just changes. You can you can read data from network diagrams. You can do sub-network traces and then read the data by tracing the network and then reading that information with the network connectivity all built into it as well. So it gives you lots and lots of ways of getting to the data and writing to the data and the various configuration parameters there. So some of the things that it is kind of built to support, simplification of subtype and domain handling. It will do the transformation of the internal to the external names automatically. As I said, it supports associations, connectivity, annotation feature classes is one that we did for a specific customer. So annotations in the UN, the feature classes are really, really complex, how they're modeled and how the data is modeled together. We can expose all that out as FME text geometries, and we can actually put that back in as annotation features. So if you are using, in the UN, if you want to write annotation feature classes, this will give the ability to support that. Another one that we do is ArcPro templates. So you can create, so normally if you're creating an object in the UN, you're saying, here's one object, a pole, and you're then saying, create a structure junction in the UN, say. If you wish to, though, you could use an UN template. In ArcPro, you can create a template, which is a transformer, the units, various other bits of information associated with that as a template, a grouping of features. You can then use those templates to create features in the UN via the FME plugin as well, which just makes it better to build aggregate features. So now we're on to kind of like some use cases. So that was kind of the initial overview of the plugin, but some of the use cases, which is being used by one customer to support a system of record to system of engagement. This is a very common term. I'm not sure if you use it much in the UK or in the US rather than in Europe, sorry. But what we're finding with the UN implementations in the States is there's a system of record, which is the version that has all the edits being made. It's got lots of versions associated with it. But then when you want to deploy that data for people to use for like mobile applications or web-based applications, having all that burden of all the additional alternatives, the versions, the branch versions, makes it harder for it to work. As we recommend to use an approach like this, a system of engagement, where you basically synchronize the data out of that system of record into a system of engagement, and then you access that with your read-only applications. The plugins that we have can support that incremental change detection from the UN to update the system of engagement to make it easier to work with the data without impacting your main design update system of record itself. Trace-based extraction, we just added this just recently, so that's why it's kind of in here, the ability to define subnetworks, so you can select subnetworks from the parameters when you set the reader up, and you can say, go get this subnetwork, and if you want to, you can actually use saved trace configurations. I don't know if people use that over here very much, but in the UN, you can actually save trace configurations, which are the stop conditions and the barriers, etc., associated with it. You can pull those out and we can expose them through FME. So I can say, go get all these features, trace, starting with this subnetwork, starter element, whatever, but use this trace configuration, which may control how I can get from one. So you basically can say, I only want to trace existing features, or I want to trace existing and proposed, or I want to trace existing, proposed, and abandoned. Trace configurations can be set up to support that capability for you. The trace results, when they come out, the only thing that's interesting here is we get this RPro connectivity list attribute that exposes the from and to node information as attribution. So this trace, one element that we're looking at goes from object ID this in network source 12, which is some layer, to another one, and then it goes via, which is the edge object. So you can expose that connectivity and it will show all that information for you. CAD import, here's another use case that we're doing. This is with a Canadian customer. They want to basically read in CAD data from vendors that deliver land-based and some features that they're digitizing into the UN. We can basically pull that in using the plugin as well. It's just a standard function now with the writer capability, but it's something that they couldn't do beforehand, or they struggled to do beforehand. There's a lot of additional kind of checks and stuff that go on in that approach. The change detection itself, so in the UN, there are, from what I've seen anyway so far, two main ways that you get changes from the UN database. One is you go to a version and you say, what is the differences to this version compared to its parent, which is SD default. Or you can say, go to the version itself, and or the feature server rather, and you can say, use the extract changes, which is the second option there. And that second option, the extract changes, allows us to go and get changes from the default against the historical moment, which is a timestamp akin to the epoch 1970, January the 1st, at 12 o'clock in midnight. So basically that extract changes capability will give us a delta sync. So when we're getting changes, we can say, go get the changes from when we last run it again, it'll get the changes from the last time, and it will just incrementally go through. We call that a delta sync. It's recording the last time it extracted data, and then it gets the changes again from the next version onwards again. So that's a really powerful thing that we're using for the change detection for the synchronization operations. And then the only thing to mention there is the FME DB operation, which is a standard FME attribute to say, is it an insert, update, delete? We automatically annotate the features with that bit of information. Here's an example of integrating with the ArcPro client. We can do it with Small World as well. So within Small World, if you wanted to extract data and throw it into a downstream system like a CAD-based design system, which is a thing called AUD, which is a system that we actually write as well. But basically what we're in the GIS itself. You say, I want to take the data and put it into my CAD system. I draw a box, I press the button, draw a box. It then calls an FME workspace in the background, creates the AUD design file, and opens up AUD so we can see the data now imported into the design in anticipation of making changes for the future. So when I'm building a new design in a specific area. Network-based extraction. So networks in network diagram rather in the utility network is where you can save a heterogeneous collection of features. You basically, in Small World terms, it's like a scrapbook. If you're familiar with Small World, same kind of thing. You can save a group of things. It can either be sourced from a trace, or it could be sourced from selecting a box, or whatever other kind of predicates you want to put together. You can save those as a group of things in the UN. We can then say, go get those using FME. So we want to do stuff with them downstream. Here's another example we're doing. So when you are in the UN, if you make changes in your alternatives, in your branch versions, if you want to post those changes, reconcile and then post those changes, you can only do it one at a time. Only one user can be posting to SDE default at any time. You can only have one person writable in SDE default. If you have a system where you have 100, 200 users of the UN, everyone's making changes in their version and they want to post those changes, it's unreasonable to expect them all to be able to do post those changes. So instead, what we're seeing is people want to say, I've finished the work in my version, I then ask a job server to go and say, schedule to post my changes up so it doesn't sequentially, user one, user two, user three. I can just finish my work in my design alternative and say, okay, I'm done for the day, schedule for post, and then in this instance here, we're using FME flow to basically say, do the version reconcile post engine. So this is just sitting waiting for requests being put in from the Arc Pro client to say, I've finished with this version, go and post my changes now at this point. So you put in a request, the FME flow server sees that request, it schedules it, it sequences them with all other requests to do the same thing, so we can then basically make sure that we're not getting like deadlocked in terms of writing to the parent. Another example is a QA/QC engine, basically validating the data that you've got in your version. Users don't want to sit there necessarily and wait for a process to run for 15, 20 minutes if there's a lot of stuff that needs to be validated. So you can basically make a request to say, get the QA or the FME flow job server to do the process when it can and send me back the results afterwards. Design processing engine, service request to UN, this is like a preprocessor for another system, and then finally this UN sync engine, which is basically our system of record, system of engagement. That's done by FME, but it's done by scheduling a job with the engine, with the FME flow server, which then picks up and schedules those requests so it can sequence them when necessary. PLS CAD integration. So PLS CAD is like the largest transmission design company, I guess, in the world. I think they have like 95% of the market for electric transmission design. We have customers who say they want to be able to get that data out of their PLS CAD design and load it into the utility network. So with FME, we can basically read the XML output from the PLS CAD design product. We can build the three-dimensional network with all the connectivity and the features and the heights and everything all done, and equipment, put them on, and then basically write that into either a CAD design tool or into the UN so that you can actually record that information there. So, go as fast as I can. I've only got a couple of slides left. BIM integration. So this is another big thing we're seeing at the moment. We're doing work with a electric transmission operating company, one of the largest ones in Europe, actually, called Tenet. That's it. So they basically do a lot of stuff with Revit, which is a 3D modeling software in AutoCAD, or with Autodesk rather, from Autodesk, which you can read that data into an FME workspace using the surfaces or as a wireframe. In this instance, I've pulled in a substation design in wireframe, and then we're taking that data and we're identifying the paths of wires, the centroids of points, the multi-centroids of multi-points. So some of these things here, they basically have like 3 or 4 different points where the wires come in. We're identifying those points so that they can take that information, which is held within the substation design files in Revit, and convert it into a linear set of features that can then be imported into UN with terminals associated as well. So we can have the wires going to the correct terminals on it. And we're kind of building out a proof of concept of that at the moment. I mentioned it just because it's actually really, really interesting and very current to what we're doing at the moment. To support all this process that we're doing, now I know the UN or FME, and the big push is no code FME, you're basically using the transformers. Unfortunately, I'm a developer, so I write stuff. I have to write programs. So where in some cases you could probably stick together a bunch of transformers and do it, I'd much rather write my own transformer and do it. So I write buckets of these transformers all the time. So in support of our UN implementations and customizations, we've written a whole load of these transformers to support specific cases. Here's one that we wrote. An ArcPro feature query allows you to say, I've got a trigger feature coming in, go find some stuff about other objects that are in the UN and merge them together, but do it with a much more complexity in terms of the attribution combinations and stuff. So we can do all sorts of things with this stuff. So this is one that we use quite a lot. feature validator. I have a feature, I'm just about to write it into the UN. I can pass it through this transformer and it will validate subtype and domain values, contingent values, which is like catalog fields in Small World, if you're familiar with that. Associations, is it valid to have an association from this structure junction to this electric device or whatever? Is it valid to have that association based on the attribution of the features that you're sending in? And basically allows you to say, is this feature going to be valid, or will it be rejected by the UN if we attempt to write it in? Then you can mitigate and try and fix it if there's a problem. ArcPro get feature updates. This is really cool, this one. So, and I'm reading changes from the UN. It will tell me what has changed about the feature, and it will also tell me if I'm about to write a feature into the UN, it will say, these are the attributes that have actually been updated. So this is the net change that will be occurring as you write things in. So in some cases, if you're getting changes from the object in the UN, it may be that it's being changed because it's been associated with a subnetwork. You're not really interested in knowing that. I'm too late, aren't I? Yeah, sorry, I'll carry on. This is a list of all the rest of them there, so that's it. Ta-da!